So if I were to get one of your big posters out yesterday, I think if I asked you to just draw a sketch of that picture, you would draw a wave, right? Okay, so we spent all this time generating the graphs of that. I'm not going to talk about that because you learned about that already. You got from the unit circle how it produced these curves. So today we're going to talk about the equations of these curves when you do things to them and how they affect the curve, and then we're going to sketch some graphs. So something that I will either write on the board or you'll have a piece of paper that tells you this is all of the different parts or things that could happen in a sine or cosine curve and what they mean. So the very first thing that could happen is I could put a number in front of your sine or cosine curve, okay? Now, and then down here we'll just put a graph of the ones you guys did in class so we have access to that. That's not on a big piece of paper. The sine and cosine curve, think of the unit circle. Do you remember the most it went away was one spaghetti noodle, okay? I remember the furthest it went away was one spaghetti noodle. So the sine and cosine curve, normally the furthest it goes is one up or one down, a wave between 1 and -1. When we put a number in front, what that does is it either stretches those maximums and minimums or it compresses them, and we call that actually A for the amplitude. So the absolute value of A is going to give us the amplitude. Which is just the height of one arch of the sine or cosine curve. Okay, so how many degrees did we say it took for the sine or cosine to repeat? Does anyone remember? Good. 360 I'm seeing, okay? What happens with the next thing we see is if there's no number in front of the x or the angle, the period is 360. But if there is a number in front, what we do is we take 360 and we divide it by the absolute value of b. All that means is we just make, what if b is negative, we make it positive. And that becomes the new period of our function. Okay. Related to period, we should talk about cycle or frequency. So another term you might hear is frequency. If I ask you what the frequency or cycle is, that's very much related to the period. It would just take one cycle per period, depending on what that period is. So I'd say one cycle per 360 degrees, for instance, for just a regular old sine or cosine. Okay, today we're going to just, because this is new to us, we'll stick with practicing graphing these kinds of things. What we're going to move on to as we go on through the week is H and K. So let's take a look at those two things. For our H value, what that does is it's going to shift the graph right and left. And for some reason with sine and cosine curves, I didn't make this up. We have a special name for it, and it's called a phase shift. I just need you to know that I've told you that. If you want to just call this a horizontal shift, that's fine. And finally, What that K at the end is a vertical shift, up and down. Okay. I needed you to have all of this stuff down because that's what we're gonna use all of this week. But like I said, today we're gonna just look at changing the amplitude and period and how that affects the graph. All right, first of all, what I would like us to do is just graph the sine and cosine curve like we did on our big piece of paper last week. And what we're going to do is we're going to go 360 to the right and 360 to the left. We're going to graph two periods of it. And what I'll tell you about our two periods is what I tell students is I like to put, sometimes I don't even like the grid on there. I like to put the period on there, and then I like to kind of cut it into 4 equal pieces and just draw a nice smooth curve instead of plotting a bunch of points. So what we're going to do is let's start our curve here. I'm going to make my scale nice and big, so after 2 tick marks we're going to make that kind of a bigger tick mark, after another 2, after another 2, and then it's going to end over here. Okay. Just to make my graph look a little bit bigger and to give myself some room, I go from 1 to -1, but I'm going to put 1 up here and -1 down here. Okay. So before I start graphing, what's going to happen is we're going to put 360 degrees here. And this curve is going to do 1 cycle in that 360 degrees. Okay. The reason why I like to cut it into force is I'm not going to make you graph all the things that were on the spaghetti noodle. What we want is we want to hit the middle, the top, the middle, the bottom, and back. Okay? And that's why I put those tick marks there. So we're going to start the sine right here. At the first tick mark, which in a second I'll label it, this is now going to go up to the max, which was 1. At the second tick mark, it's going to go back down to the midline. At the next tick mark, it's going to go down to its minimum. And then at 360, back to the middle. And then we're drawing a nice curve through it, like you guys did such a nice job of on your activity last week. All right, let's fill in the tick marks. This would be 180 degrees, right? This would be 90 degrees. And then this would be 270. Okay, now let's do the same thing on the other side. So every 2 we're going to make a tick mark. This is -90, -180, -270, -360. Okay. If I reversed it, if I went backwards, where should I go? Should I go up or down? Yeah, follow the pattern. Good. I'm going down at -180 back to the middle, at -270 to the top, -360. Okay, and again, I'm just going to connect that. Here's the thing, guys. As long as you can figure out the period and just put 4 tick marks in between, then you're going to always be able to graph a cycle. Because if the period stretches out, that's fine. It's just that those points, the max, the zeros, and the mins, they just get stretched out. So I always start with what is the period of the curve, and then I go from there, and then we just graph cycles. Okay, so this is just a sine curve, sine x or sine theta. All right, now let's see what you remember about cosine. Here's the deal with the cosine curve. It looked very similar, so we're going to do the same thing. It's just that the cosine started at its maximum rather than in the center, okay? So let's label this 1, -1 again. I'm going to take every 2 tick marks, make that 90, 180, 270, 360, and I'll go the same thing in the opposite direction. Okay, now this time, guys, we're going to do the same pattern, but we're going to start at the maximum. So if I started at the maximum, I only have one choice. It's going to now, at the next tick mark at 90, it's going to go down to the middle. And then it's going to go down at 180 to its minimum, back up to the middle, and back up to the top. So, all right, and then let's do the opposite direction. Okay. Let's see what I have for us. I'll leave that up there while you're finishing. And this is our cosine curve. It's important to know where these curves start, because if I change the curve, I'm going to be referencing these two graphs a lot. Like, oh, this is where we start. We call these the parent function. This is where it starts, and then we're trying to figure out where we end up. Okay. So what we're going to do then today is we're just going to change our amplitude and periods. So just a reminder from earlier on, if you see these two curves today, this A is the amplitude, and this is going to change the max and the min around. And then to figure out the new period, I'm going to take 360 divided by the absolute value of B. And that's going to give me my new period. Okay. What if there's nothing in the place of B? Well, then the period would stay at 360. All right, first example. What if I changed this to 2? Identify the amplitude. The amplitude is 2. Do you see that there's nothing here? Well, there's a 1 there. The period is just still 360. Okay, so here's what happens when I do that. Do you remember over here, the cosine curve, the highest it went was 1 and -1. Well, if the amplitude's now 2, I need to make that go up to 2 and -2. So when I'm sketching my graph, here's my 1, I'm going to make this go up to 2. And that's -2. Okay, since I didn't change my period at all, I'm going to do the same thing I did last time. So I'm going to take 2 tick marks, and that's 90 degrees, 180, 270, 360. Okay, now, this is a cosine curve. Cosine curves always start at the top. The top of this one's going to start at 2. Okay, so here we go. Starts at 2, now goes at 90, it's going to go down to the midline. At 180, it's going to go down to its minimum. At 270, back to the midline. And then 360 up here. So you can see that amplitude changing, and then we'll backtrack. Okay, next one. What if on this one there's no number in front? So, well, there really is. It's just that from the original sine graph or sine curve, the amplitude didn't change. So for this one, the amplitude is just equal to 1. So we're going to, this one, go back to making our curve up to 1 and down to -1. 4 theta is the same as 4x. The period is 360 divided by 4, which is what? 90 this time. Okay, now, what I'm going to do now, I'm not going to totally keep this 360 the same, but I'm going to make sure that it has to complete one cycle in 90 degrees. So I'm gonna, to fit this on my graph, I'm gonna just scale that down, and I'm gonna do my, remember I need 4 of them. 1, 2, 3, this will be my 90, okay? I'm gonna keep this the same, but it's just gonna, I'm gonna have to squeeze it in there. Okay, now there's not a lot of space in here to put everything, so let's at least do, this is 45 degrees, right? And then sine starts in the middle of the wave, so we're going to start this at 0. All right, so here we go, but squeeze it in. It's the first tick mark goes up to 1, at 45 goes back down to the middle, down to -1, and then to 90. So it's squeezing a cycle in there, and I'm going to just go continue that pattern. So 1, 2, 3, 4 would bring me to 180, and I'm going to keep going.